Alright, we're going to look at the examine command now, and again you have your SPSS file open, and this is your syntax command that we've done thus far. So let's go to Analyze, Descriptive Statistics, and let's go to Explore. We've looked at frequencies, which gives us counts and percentages. We've looked at descriptives, which gives us basically all the statistics that we're familiar with: the mean, median, mode, skewness, kurtosis, all the dispersion statistics, standard deviation, and so on. Now we're going to look at Explore. And in Explore, I've got some variables here already, but let's see what we want to do. Let's say that we do want to use men and women as a category, and let's say that we want to look at income, okay? And let's say we want to look at descriptives, which is going to also give us 95% confidence interval, and we could always change that to a different value, but for now let's leave it at 95% confidence interval. And let's say that we want to look at outliers. You could select percentiles or M estimators, but I'm going to leave those alone right now. And I don't want a stem and leaf plot, so if you have that checked, go ahead and uncheck it. I do want a histogram, and I can ask for a histogram because our dependent variable income is intervally scaled, and I want normality plots with the test. So let me go ahead and here, if I only wanted the statistics versus the plots, then I would select whichever one I want, but I want both. And so here's the syntax that I get, and I'll go ahead and annotate that as soon as I show you what that is. So we have our syntax. We can run it, and you see that you get quite a bit of information when you use the explore function. So first, of course, there's your syntax, and you get the case processing summary, which always tells you, how many valid cases you have. We have no missing cases. And then here you have the descriptives, similar to the descriptives that you get when you use Analyze, Descriptives. But in addition, you also get the 95% confidence interval. You get the trimmed mean. Remember, we talked about trim means being more robust. You get the median, the variance, and then your measures of dispersion, including the interquartile range, and the skewness and the kurtosis. And that's for men and for women. And then you also get, because you asked for the outliers, the most extreme cases, and you get the highest 5 and the lowest 5, and it tells you what case number. So you could go back and look at your cases. So you could look at your data set if you were interested in finding out what was going on there, and you could go to income, and you could go to case 223, I believe that was. There it is. And so that is the most extreme score, but still looks reasonable within the other incomes. But it tells you exactly where to look, what case number, and what the value is. And so you can look at those in comparison to your data that you have. You also get these two estimates of normality. Now the KS test and the SW test are both tests of normality. The KS test has been criticized somewhat, but SPSS here now includes only if you use it through the explore command, because if you use it through the non-para command, you won't get this. But through the explore command, you'll get the Lilliefors correction, which makes it a little bit better, but the Shapiro-Wilks is also something good to look at. So what we're looking for here are values that are greater than 0.05. If we're looking at an alpha of 0.05, meaning that we're willing to be wrong 5% of the time. So less than 0.05 would be, if we had a value here in the sig column, less than 0.05, that would signal to us that perhaps our sample is not normally distributed. And another thing that you could do, since you have standard errors, is you could do a test statistic and that is simply, you could take the skewness value, which is the statistic here, divided by the standard error for the skewness. So you would take, for example, 0.017 divided by 0.198, and that gives you a 0.08. And as long as this number, the skewness divided by the standard error for skewness, is less than 3, some people are more conservative and use less than 2, then it's considered still within the range of normality. We could do the same thing for the skewness, for the kurtosis. So 0.256 divided by 0.394, and we get a 0.649, still within the bounds of what we would consider normal. So you have several options in order to explain that your data is or is not normally distributed. So according to the standardized skewness and kurtosis by dividing the statistic by the standard error, the test statistic, you can say that your data is fairly normally distributed for men, and you would do the same thing for the women. Or by using the Shapiro-Wilks or the Kolmogorov-Smirnov test, you could say that your data by group is normally distributed. And here we have the distribution that you could actually look at, and if you double click on this, you can superimpose a normal distribution, and there's other distributions available to you. And you can see that it's fairly normally distributed. And here is the one for the women. And again, you could superimpose a normal curve. And you can see that it's fairly normally distributed. Again, a little skewness there, but fairly normally distributed within reason. So then you would say that's okay. What I prefer, which I think is very easy to look at, is a QQ plot. And what you're looking for in a QQ plot is you don't want any kind of weird pattern. You want it as much as possible to line up along the line, and so that hence is a good hint for you that that is normally distributed. And so here we have the dots are aligned in a diagonal, so I feel very comfortable that the men are normally distributed in terms of income, and that the women, there's a little bit of a something going on there at the extremes, but in general normally distributed. And then we have the box plots. And the box plots, remember we said that the solid line in the middle is the median at the 50th percentile. And then we have the interquartile range here, and we have our fences. Here, notice that you get a value, meaning that case 103 is beyond your whiskers there. So, you might want to look at that point. It's not an extreme outlier, but it may be something that you want to consider. And this is divided by women and by men. So if we look at case 103 in your data, you can see that this value, 14,859, is what's being displayed as pretty low here in terms of income for women. Okay, so that's hopefully you can see all the information that's provided to you with the explore command. I prefer the explore command to the descriptives command, although you can get some of the same statistics but not all of them. You can get box plots, you can get histograms, which we could get before, but you can impose a normality plot over that. You also, when you request the plots for normality, you can get the QQ plot. You'll also get the, which is the one that I prefer to look at, but you also get the KS test, and you get the Shapiro-Wilks test for normality. So it allows you to do that. In addition, one thing that's available with the explore command that I like a lot is you get trimmed means, you get 95% confidence interval, or whatever confidence interval you would like to have. You can change that here. You can change it to 90 or 99 or whatever you prefer. And the extreme command allows you to see the outliers on a case-by-case basis, which is nice. And of course your nominal scaled variable breaks it up. But if instead you did not want to look at by female, you wanted to look at income overall, you can rerun this, removing the by statement. And now you will get the same information, but notice that now you get a 95% confidence interval and a trimmed mean and so on for the entire set, regardless of men or women, and you get the most extreme scores regardless of whether they're men or women. Again, your normality, your histogram, your QQ plots. Let's see. Oh, of course you only have one QQ plot because you are taking them regardless of gender. And so if you do include the by statement, then you can divide it up by groups. By statement allows you to divide the variable into groups, but you can remove it. So that's important to know. So typically when you're writing up your descriptives, you'll probably want to run the examine command because it gives you so much of what you want. Of course, that's with intervally scaled data. The examine command would not be very useful if you just ran it on nominal data, because nominal data, as we already saw, you can only run particular statistics on because it is nominally scaled. So that's another option to you now.